Hello, good morning everyone. Last lecture we learned about the ARM7. I given you idea about the ARM7 introductions. Now we are going to see ARM7 features. Okay, so I club ARM7 and ARM9 features in the slide. Okay, so we see one by one what are its features. So see here, first one feature is it has 32-bit or 16-bit core. Okay, it is a risk architecture. Okay, so actually this ARM7 family is extended from the ARM V40, means fourth versions. Okay, so this ARM7 is a 32-bit or a 16-bit core. It is like this. It is written like this because actually this ARM7 will have utility to work in either 32-bit mode as well as 16-bit mode. That's why it is written like this: 32-bit or 16-bit RISC architecture. Second feature is like this: it has a 32-bit ARM instruction set for maximum performance and flexibility. So it has a dedicated instruction set. That instruction set has all 32-bit instructions. Okay, it is giving a lot of flexibility while execution or while writing a program, as well as its performance is very better as compared to the other one. Okay, so that's why here it is said like this: it is a 32-bit ARM instruction set for maximum performance and flexibility, right? Then 16-bit thumb instruction set for increased code density. As I told you that that is giving the first feature description like 32-bit and 16-bit. So here it is a 16-bit thumb instruction set. Okay, it has increased code density. Okay, actually this mode is important for the different designers or programmers. So that's why they are switching the ARM7 from 32-bit to 16 and 16 to 32-bit. Because of this code, the earlier older program can easily club with your advanced controllers. Okay, so that's why this feature is very better for clubbing that instruction, where your program is written in 16-bit. Okay, and it has some dedicated instruction set also. So separate 16-bit thumb instruction set is also provided. Okay, so those programmer who are very much familiar with that 16-bit code, okay, that they are writing their program in that 16-bit by utilizing that thumb instructions. Okay, and those who are aware that 32-bit instruction set, so they are utilizing that particular instruction. There is no issue. Okay, both program written by either in 16-bit or 30-bit, both are executed or executed by the ARM core very flexibly. Okay, so here programmer is independent of the core, so that's why he may write their program as per his own choices. Okay, then unified bus interface is there. Okay, whatever the bus interface which are available with this ARM core, okay, is very better. Okay, so here you can find 32-bit data bus. It will carries both the instructions and data. Similarly, here you can find it has 8-bit, 16-bit, and 32-bit data types. Means programmer will easily write his data in either in 32-bit fashion, or he may write in 16-bit fashion, or he may write his data in 8-bit fashion also. So that's why there is a data path. So because of that data path, you can able to differentiate all these data types with the help of these 8-bit, 16-bit, and 32-bit mode. Okay, then especially the pipeline is one of the important features. So here This ARM7 has a 3-stage pipeline facility. Okay, this issue is now increasing as you can go for the different versions of this ARM7. Okay, so you can find 5-stage pipeline, 6-stage pipeline also. So ARM9, ARM10, or ARM11 will have extended pipelining feature. So we see how the 3-stage pipeline facility will be here. Okay, then it has near about 4 GB linear address space is available. Okay, because of 2 raised to 32, near about 4 GB memory interface capability will be available. So because of this, you can able to find near about 4 GB address space will be available for the programmer while programming. Okay, so this feature is one of the major important for writing the program. Okay, as well as a programmer will find adequate space for providing to the customers also. Then 32-bit arithmetic logic unit will be there. Okay, it has high performance multiplier will be clubbed with this. Okay, so all arithmetic and logic unit operations are carried out with the help of this 32-bit unit. Okay. Then it has near about 37 pieces of 32-bit register. Okay, so that's why here whatever the register which is available, it has near about 32-bit length. Okay, so near about 37 register are available internally, are of 32-bit. We will see the special structure of this register one by one. Okay, so here as per the die size point of view, it has very small die size and low power consumptions. It has fully static operations. It has a co-processor interface is also available for different numerical data processor as well as any other co-processor. You can easily interface with the ARM7. Then extensive debug facility is also available, like ICERT real-time debug unit will be there, that is embedded ICRT. Similarly, on-chip JTAG interface unit is also available. Then interface for direct connections to embedded trace micro cell will be there. Okay. Similarly, here you can find the cache facility, as I already told you that it has a cache facility, pipelining facility. So that's why these two facilities are available. Then it utilizes a one Neumann type of bus structure. Okay, ARM7 will carry near about this, but in terms of ARM9 you can find the hardware type of architecture. Near about this controller will operates in 7 different modes. So that's why these 7 different modes are listed here, like user mode, fast interrupt request mode, supervisory controller, abort mode, system mode, and undefined mode. Okay, so that's why these 7 modes of operation are possible with this ARM7. Then it has simple structure. Okay, it is reasonably good speed, and power consumption ratio is also less. Okay, it has low power or very low power consumptions, so that's why it is a industry leader controller or processor in MIPS or per watts. Okay, so that's why this will be the beauty of this controller. And here these are the features of this ARM7 or ARM9. Okay, now I'm going to tell you here classifications of these ARM processors. Okay, so that ARM processors are divided into ARM classic processors, ARM embedded processors, and ARM applications processor. Whenever you talk about this ARM processor, because most of the students are facing these problems, or how I see which processor will be used for which type of application. So that's why I added this one slide for your understandings point of view. because whenever you enter into the market, that time many controller are available in front of you. Okay, when you have to design any kind of application, so that's why I am giving you an idea that how you can able to differentiate this. Okay, so here many ARM controller or processor are available in the market. Okay, if you see the market ratio, okay, there are a lot of manufacturer available in the market, and everyone manufacturer is going to design the parallel ARM controllers or processors. Okay, so that's why the issue will come in mind that which will be suitable for me. So that's why here I given you a brief summary about this ARM processor. So that's why here you can look the ARM family is classified into these ARM classic processors, embedded processors, and applications processor. Okay, I am telling you one by one. Now see, I am telling you here about the classic processor. Okay, the ARM classic processors include ARM 7, 9, and 11 families, and ARM 7 TDMI is still the highest shipping 32-bit processor. ARM 7 based processor are still used in many small and simple 32-bit devices. So that's why you can able to see these are the ARM's classic processors are available in the market. But if you talk about the embedded processor, so that's why the embedded processors available in the market will be like this. Okay, actually, it is a Cortex name processor. Okay, actually, this is also one of the competitor available in the market. So that's why the ARM, okay, controller or the ARM processor or a Cortex processor will be there in the market. So here now we see about the embedded processor. So even though ARM 7 or other classic ARM processors can be used for small scale embedded system, newer embedded systems are built using the advanced ARM embedded processors or the Cortex M processors and Cortex R processor. Okay, the ARM's Cortex M processor have microcontroller profile, while the Cortex R processor have a real-time profile. Okay, so here you can see the differences between the real-time and microcontroller profile. Okay, actually, you are aware with the 8051, so that's why you have idea about the microcontroller. Okay, actually, the microcontroller. You can see it has a, dedicated on-chip on-chip peripheral are there. Okay, you need to program everything. Okay, and according to the programming, you can handle the different peripheral devices. Okay, but some real-time processor are also available in the market. Okay, so that's why because of that real-time behavior, you can able to implement the real-time nature in the programming behavior. Okay, so there is a real-time functions. Okay, they can be easily clubbed with your programming. Okay, so I will give you an idea about how the real-time operating systems will be clubbed with your controller. Okay, because it has many features. Okay, it has many schedulers will be there. Okay, because of that schedulers, you can able to implement that a real-time behavior. Okay, so we will see it one by one, but now at this moment I am giving you just a brief summary about that real-time profile processor. Okay, so that's why this is a Cortex R1 processor that are coming under the real-time profile, but Cortex M will be coming under the microcontroller profile. So if you talk about the Cortex M processor are energy efficient, and they are simple to implement and are mainly developed for advanced embedded applications. Okay, so ARM Cortex M processor are then divided into several processor cores like Cortex M0, Cortex M0 Plus, Cortex M3, Cortex M4, and Cortex M7. Okay, so these are the microcontroller profile embedded processor. But if you see Cortex R4, R5, R7, and R8 are a real-time processor. So here, this is a dividation between these embedded processors. Okay, now here again now just going through this here you can find these real-time embedded systems are also okay. So Cortex R series of processor provide solutions for a real-time embedded system. They provide high reliability, high fault tolerance, and real-time responses. Cortex R series of processors are used in system where high performance is required and time deadline is also important. Okay, so when you talk about the real time, that time the deadline will be important. So as I told you in the first unit also, what is the use of the real time operating system? So that's why there is a specific deadline will be given, and within that deadline, that controller will able to work. Okay, so that's why we will say it is a real time controller. So this such fashion is now okay. Actually with the help of software in earlier days, with the help of software, that fashion was adopted. But nowadays, okay, as I am telling you here the latest trends point of view, okay, now such controller are now all available in the market. So they are following the real time deadline. So that's why this is the beauty of the designers. So that's why they are giving such a time deadlines in your controllers. Okay, so you can find Cortex R4, R5, R7, and R8 processors are available. Okay. Similarly, we can talk about the applications processor. So that's why here applications processors are also available. Now questioner is here, for which applications I use these controllers. Okay, I use this processor. Actually in earlier slide, whatever the controller that or processor I show you, okay, they are dependent on the applications. Okay, means ARM 7, ARM 9, and ARM 11. Similarly these Cortex 1, okay, they are used for embedded. But now here, which family will be coming under this application processor? So that's why here, and where I use these application processors family. See, uh, ARM Cortex A series of processor are highest performance processor from ARM. They are used in powerful mobile devices. Okay, compelling technologies, product like network devices, consumer appliances, automations systems, automobiles, and other embedded systems. So that's why here, these application processor are again divided into three different categories. You can see high performance processor will be listed below. Okay, then high efficiency processor are listed, and then ultra high efficiency processors are listed. See, Cortex A73, A72, A57, and A17 are listed under the high performance category. So where you need high performance processor, so there you can utilize this family. If you need a high efficiency, then as per your product, embedded product point of view, you can choose this processor. Okay, so that's why A53, A9, A8 family will be there. Okay, it comes under the high efficiency. And similarly, ultra high efficiency like A35, A32, A7, and A5, this family will comes under that for ultra high efficiency. Okay, so this is about the applications processor. Okay, so this will be about arms. Okay, various types of arm processors are available in the market. So that's why these slides are dedicated for these things. Okay, because here it is very highly difficult that which processor I use for the different application. So I think this will enough for your information's point of view, because it will give a near about idea which are the classic processor, which are the embedded processor and application processor. Okay, so actually I have not given you idea about what is the use or what are the features. Okay, but just I listed here. Okay, what is, which are the classic, which are the embedded and applications processors. Okay, so I think this information will be quite enough for your understanding. Okay, just by observing you can utilize this controller for your applications. Okay, now I'm giving you idea about the different advantages and disadvantages of this ARM processors. Okay, now, if you see, if you are going to study this ARM processor, the question arises: what are the advantages? Okay, so here this slide will be dedicated for that. What are the advantages of this ARM processor that you can see? Here, the first advantage is affordable to create. Okay, actually, whenever you are going to design an application, so that's why while designing, you may think about the price. Okay, you may think about the cost. Okay, you may think about whether my product will get sold in the market. Okay, whether a customer will be able to purchase my product. Okay, or whether a customer will find any problem while purchasing, its cost will be higher or lower. So according to that, here it is affordable to create. Okay, actually ARM processor are affordable. Okay, ARM processor are is very affordable, as it does not need expensive equipments for its creations. Okay, so that's why whenever you are going to design any one of the product in any place, okay, so that you need cheapest equipment, okay, while designing your product. So that's why if you find a very cheapest design, so that's why you can able to sell that your product in the market at low cost. So that's why when compared to other processor, it is created at much lesser space. Okay, this is why they are apt for market of low cost mobile phones and other electronic devices. Okay, so that's why because of the beauty of the small die size here, uh, you can accommodate in any application, and you can easily sell it into the market at low cost. So that's why many electronic devices, many mobile phones, okay, the mobile phones which comes since 2007 are adopting this ARM processor. Okay, so if you open your mobile also, then at the back side of that controller, you can see the ARMS processor, ARMS technology. Okay, so that this technology is cheaper one, so that's why everyone can easily purchase it. Okay, and a customer will be satisfied to choose and utilize it. Okay, because of a lot of features will you getting with smaller prices. Okay, so that's why here it is affordable to create. Okay, mean manufacturing is also very easier, as well as the selling is also easier. Okay, so that's why it is affordable to create will be one of the advantage that given by the designer. Okay, similarly low power consumptions. Okay, as you talk about the power consumptions, okay, whatever the product which you choose in the market, okay, that will run whole day, or most of the product are running multiple days also. Okay, they are running hour to hour. Okay, so that's why there is no issue of draining of batteries very fast. Okay, so that's why here uh, ARM processor have lesser power consumption. Okay, here you can find okay, they were initially designed for performing at lesser power. They even have laser transistor in their architecture. Okay, they have various other features that allows for this. Okay, so that's why here you can say it has low power consumption, because this is the beauty, it has less number of transistors are available in the architecture. So that's why the power consumption is obviously lesser. Okay, so that's why this is one of the internal core features, huh? Right, see, then it works faster. Okay, generally ARM performs single operations at a time, so that's why this makes its work faster. Okay, it has a lower latency. This is a quicker response, this that is quicker response time. Okay, so that's why as you see, okay, its executions is not dependent on the other one instruction. So that's why here only one instruction will get executed at a time. Okay, and it has faster executions time. So that's why the latency time will also reduce. Okay, so we can say it will works faster. Then multi-processing feature, obviously it has a multi-processing feature. It is a beauty of a software. So that's why ARM processor are designed so that they can use in case of multi-processing systems where more than one processor are used to process informations. Okay, so that's why the first ARM processor introduced by the name ARM V6K had ability to support 4 CPU along with its hardware. Okay, so that's why here you can say it has multiple core, and because of that multiple core you can able to execute it very fast. So that's why this multi-processing facility is available. Then better battery life. Okay, here as it has low power consumption, so point of view here you can find ARM processor will have better battery life. Okay, this is seen from administrating devices that use ARM processor, and those that do not. Okay, those that are use ARM processor work for longer and got discharged later than those that did not work on ARM processors. Okay, then a load store architecture will be there. The processor uses a load store architecture that store data in various registers. Okay, it reduces the memory interactions. It has separated load and store instructions that are used to transfer data between external memory and registers banks. Okay, so that's why this is the beauty of load store architectures. Okay, then it has simple circuit. Okay, ARM processor have simple circuit, hence they are very compact and can be used in devices that are smaller in size. Okay, so that's why here you can find these are the advantages of this ARM processor. Okay, now you can find these disadvantages. Okay, because whenever you find any trend or any technology, then every trend and technology will have some kind of disadvantages, drawbacks. Okay, so that's why I'm saying you here the drawbacks also. Okay, so here it is not compatible with your x86. Okay, hence it cannot be used in Windows. Okay, so it is not compatible. So that's why it required only embedded OS. So that's why here you can find it cannot be used in Windows. Okay, the speed are limited in some processor, which might create problem. Okay, here the speed are limited in some processor. Okay, most of the cases, most of the versions in you can find it has some speed problem. So that's why that might create problem in design as well as in running the same applications over the multiple processes. Okay, so that's why you need to design the different softwares for the processors versions point of view. Okay, then scheduling instructions is difficult in case of ARM processor. Whatever the scheduling, okay, that I told you that in terms of RTOS, you can find the scheduling will be needed. So that's why that scheduling of the instruction is difficult in case of ARM processors. Okay, so that's why here it might create problem. Okay, then there must be a proper execution of instructions by programmer. Okay, this is because entire performance of ARM processor depend upon their executions. Okay, similarly the ARM processor will need very highly skilled programmers. Okay, because this is because of importance and complexity of executions. Okay, so processor shows lesser performance when not executed properly. Okay, so that's why here highly skilled programmer will be needed. So that's why they will trace whether the complexity will coming in the instructions, okay, or processor is going to overload while execution of that instruction. So that's why these are the various advantages that are quoted like by the ARM processor designer. So that's why here these advantages and drawbacks are important while understanding your arms controller. Okay, so that's why this particular video brings in front of you that different ARM processor, different ARM's features, okay, as well as different drawbacks and advantages of this ARM family. Okay, I hope this information will be quite enough for your understanding. So in next lecture we will start about the ARM controller or ARM processor. Okay, so just uh, st- thanks for a good listening as well as watching. Okay, so in case if you have to give your attendance, so you can give your attendance in my comment box, okay, with your roll number. So thank you very much.